Welcome back to lecture. In this lesson, I would like to talk about apportionment. How do we divide something evenly among groups? So, what is apportionment? The process of fairly assigning identical indivisible objects among individuals entitled to shares that may be unequal. So, a common example is in the U.S. Congress. 100 senators with 50 states, and we get 2 senators per state. House of Representatives is apportioned based on the population of the state. But what we would like to do is basically take that we have been allocated for our number of seats and then spread them across the state. So this is what we're going to do with this. So before we start talking about districts, we need to say what is the total population and the number of seats that we have been allocated. So we'll take the total population and the number of seats, and that gives us the standard divisor. Basically what we're going to say is a piece of the population per seat is what we're working with here. So a city has 20 seats to be allocated proportionally among 5 districts. Here we have the population. We've narrowed it down to 240,000 across these 5 districts. Notice that each one is different. The population is different, but that standard divisor is going to be the 240 divided by the 20 seats. So it's going to be, the standard divisor would be 12 in this case. So why would it not be fair for every district to get 4 representatives? So that would be 4 times 5 is 20. Well, then some of these have got more population, they should get more. So it wouldn't be fair to them. It would be advantageous for like District 5 with only 20. They're getting just as much say-so as what the district with 80. So find the standard divisor. That would be the 12. The 240, the 20 seats, 240 divided by the 20 would be the 12. And now note how District 2 has 1/3 of the population. Why will District 2 get exactly 1/3 of the seats if we work this through? That's the way the apportionment process works. So what is the standard quota? The standard quota is the theoretical number of seats that each district could get if it were possible to hand out fractional portions of seats. So if we could just divide that population of the district divided by the standard divisor, that would be how many it should get. But these are fractional pieces, and we can't do that fractional seats. We can't have members of each district being in there to make up the 1 seat. Okay, so we need to figure out what the standard quota is. That's the fractional piece, but we need an integer piece. Okay. So here's one that you could work on, finding the standard quota for each district. Again, we would do the 240 divided by the 20 would be the 12, and then the 32 divided by the 12, 80 divided by the 12, and so forth. That would be the standard quota for each one of those. Okay. But now we need to, we want to do an integer number for each one because we can't divide up that fractional piece, that decimal number. So we just either round up to get an upper quota or we round down to get the lower quota. But in all cases, whether we did this, we would need to make sure that the total number of seats apportioned out would not be greater than what we were allocated, the 20. Okay. So there are there's a number of ways that we can go through this procedure, and Hamilton's method of apportionment is the following. I would assign each district the number of seats according to its lower quota, so we'd round down for the quota. If this adds to the right number of seats, we're done. If it does not, we're going to assign extra seats one by one to the districts in descending order of size of the fractional parts in their standard quota. So if 3 districts have standard quotas, 2.93, 4.70, and 3.15, that first extra seat would go to the district with fractional part 0.93, that's the largest fractional. Then the second district with fractional part 0.70 would happen to get that, and then we would continue on down until all of the extra seats were portioned out. So here's one that you could spend a few minutes working on. Suppose the nation has 4 states with populations shown below and a representative body with 60 seats. how many seats should each state get? We could try just the lower quota if we're finished, and then we would go into the fractional part and then assign it according to the Hamiltons. Jefferson's method of apportionments assigned each district the number of seats according to its lower quota. If this adds to the right number of seats, you're done. If the sum of the lower quotas is less than the number of seats, choose a modified divisor that is less than the standard divisor and recalculate these lower quotas. So I'm going to tweak that divisor down a little bit from the standard divisor to a modified divisor, and then I'm just going to kind of do it a little bit at a time until I get the total number of seats to add up. But if it doesn't, I'll tweak it down a little bit more. Okay, so it's a trial and error type process. So here's an example that you could work on. Suppose a nation has 4 states with populations shown below and a representative body with 60 seats. How many seats should each state get? So if we did the modified divisor, we got a 24.676. So I got it down a little bit, and then I did the lower quota on that, so that would be the 24. And I'd continue on and see if the number of seats added up to 60. So here's a couple of extra ones. Here's the ones that we talk about in the lesson, and there's a couple of other ones that you may run into in the future. Here's Hamilton's. I do the standard divisor. I do the standard quota. Remember, that's the population divided by the standard divisor, the population of the district. And then I distribute any leftover items to the groups with the largest fractional parts until all items are distributed. And they say this favors large states. And then Jefferson, I'm going to do a modified divisor down a little bit from the standard divisor. I go to the modified quota, round it down, and then I'm going to portion to each group its modified lower quota, and look at that and see if that adds up to the appropriate number of seats. Webster's, I can do a modified divisor. I can be less than, greater than, or equal to the standard divisor. And here, the modified quota is rounded to the nearest integer, whichever it is, up or down. And then a portion to each group is modified rounded quota. And add them up, make sure I've got add up to the correct number of seats, and that favors small states. And Adams, the modified divisor is greater than the standard divisor, so I'm going up a little bit. And then the modified quota is rounded up to the nearest integer. And then a portion of each group is modified upper quota, and that again favors small states. So we'll look at this more as we go along, and we'll see you next time.